Good day, this is Dr. Amudapriya, Associate Professor Triply from Rohini College of Engineering and Technology. We are discussing about the power system operation and control course, where we are going to discuss about the regulation of two generators in parallel. So parallel operation, why is it required and how it is advantageous? These are the things which we are going to discuss first. Several generators can supply a bigger load than one machine by itself. Having many generators will increase obviously the reliability of the power system. It allows one or more generators to be removed for shutdown or preventive maintenance, etc. So obviously for parallel operation of the generators, synchronization is a very much important term which has to be considered and which has to be maintained for parallel operation. So this is nothing but the RMS line voltages of the two generators should be equal. The two generators must have the same phase sequence. The phase angles of the two phases must be equal. I mean, if it is considered as the A phase and A dash phase, both their phase angles should be the same. And the oncoming generator frequency should be equal to the running system frequency. This is how synchronization has been made. And how they are connected in parallel. We can have the infinite bus system. The concept of infinite buses, when a synchronous generator is connected to a power system, the power system is often so large that nothing the operator of the generator does will have much of an effect on the power system. Example of this situation is the connection of a single generator to the Canadian power grid, for example. Our Canadian power grid is so large because it's a large power grid that no reasonable action on the part of one generator can cause an observable change in overall grid frequency. This idea is idealized in the concept of an infinite bus. So an infinite bus is a power system so large that its voltage and frequency do not vary regardless of how much real or reactive power is being drawn from or supplied to it. So while considering the active and the reactive power angle characteristics, if reactive power is greater than 0, obviously it is a generator operation. If active power is less, then it is a motor operation. For the reactive power to be greater than 0, it delivers the inductive VARs for a generator action or receiving the inductive VARs for a motor action. When reactive power is less than 0, it delivers capacitive VARs for generator action or it receives the capacitive VARs for motor action. These are all regarding the power actions. Next, while considering the synchronizing and the parallel operation of alternators, the main condition is voltage, frequency and the phase sequence of the incoming machine should be same as that which are being connected at the bus bars. So for this synchronization purposes, we can use either dark lamp method, bright lamp method or synchronoscope method. So in all these methods, the power and the torque equations are being considered for modeling the system. And this will be a greater indicator of whether the alternators which are connected in parallel are being in synchronized state or not. So the synchronizing torque, you can see it is given by PSY divided by 2 pi ns bar 60. So this ns is nothing but the synchronous speed and this determines the parallel operation of the alternator.